Let's talk about degrees and radians. So some definitions here. Angle rotation is an angle formed by the starting and ending positions of a ray that rotates about its endpoint. I've got an image over here of that. We're going to have, there's our angle rotation. Your initial side is always positive x. So here, this is our standard or initial side position. And its endpoint is always at 0, 0. Now we'll be rotating our angles counterclockwise, which is going to create a positive angle. Make sure you know that that is going to be up and over. We'll create counterclockwise. So if I start in that standard position on the positive x-axis, I will be going up and over. Clockwise is when I go down and around. So again, if I start in that standard position, we're going to rotate down and around to create a negative angle. Let's start with number 1, sketching 90 degrees. Hopefully this is review. We're going to start in our standard position here on positive x-axis. We're going to rotate it up and over to create a positive angle, and we want positive 90 degrees. So hopefully you recall that that is going to be straight up positive 90 degrees. So as I sketch this, it's going to be that angle from that starting position and then straight up. Number 2, sketch 270 degrees. So I'm starting positive x-axis every time. Straight up is 90 degrees. All the way over would be 180. And then another 90 degrees would make 270 straight down. So we are going to be rotating all the way up and over to 270, from standard position all the way over to straight down. Number 3, sketch 120 degrees. We're going to start positive x-axis. As I rotate up for a positive angle, 90 degrees would be straight up. All the way over is going to be 180, and that's too much. So a couple things I want to point out is, remember, if we divide one of our quadrants into thirds, this would be 30 degrees and then 60 degrees. So every third of the way through our quadrant is 30 degrees. So if I take 90 and I add 30, so let me go another third of the way through this quadrant here, adding that 30 degrees, that will get me to 120. 90 degrees plus 30 equals 120. So let's start. Standard starting position, rotating all the way over past 90 degrees and a third of the way more to give us that 120 degrees. Number 4, standard position, we're going to sketch 225 degrees. So I'm going to rotate up to have this positive angle. We've got 90 is straight up, 180 all the way over, 270. Now 270 is too much now. So remember, halfway through our quadrants is 45 degrees. So if I did 180 plus 45, that will give us 225. So I'm going to start standard position. I'm going to rotate all the way past 180 and then halfway through that third quadrant to give me 225 degrees. So use a lot of what we know. We know 90 degrees is a quarter of the way up, or a quarter of the way around our full circle. A third of a quadrant is 30 degrees. Halfway through a quadrant is 45 degrees, so we can add up as we need. Let's look at number 5, negative. Do you see that? Negative 45 degrees. We're going to still start in our standard position on positive x-axis, but we're going to be rotating down to create a negative angle. Now it works the same way. So we just talked about halfway through a quadrant is 45 degrees. So same thing, if I go halfway through that quadrant, that's negative 45 degrees. So from standard position, rotating down gives us a negative 45 degrees right there, number 5. Number 6, sketch a negative 330 degrees. We will start standard position. I'm rotating down to get a negative angle. Now straight down, that's going to be negative 90 degrees. Keep rotating to give me a negative 180 degrees. And then all the way up, it's going to be negative 270, and we're not quite there. Now, We talked about a third of each quadrant is 30 degrees. So if I add another 30, that'll be negative 300. And another negative 30 would make negative 330. So what we're doing, starting at standard position, rotating all the way around and almost completing a circle to get to negative 330 degrees. Number 7, sketch 570. 570, that's bigger than a full circle 360, but we're still going to start at standard position. We're just going to go a complete rotation past our starting position. It's positive, so we're going to be going up and over. Now 570 minus a full circle. What if I did a full loop around? 570 minus 360 is 210. So let's do a full circle. So let's add halfway. I could still go halfway around, adding another 180. So let's subtract 210 from 180, and that gives me 30. So I know I went a full circle. I went halfway around to add another 180, and then I'm going to do a third to give me a additional 30. So we did 360, we did 180, and 30. Add those all up is 570. So let me grab my blue, starting at standard position, all the way around 360, all the way over to the opposite side, makes 180, and then that additional 30 will take us to this position of a full 570 degrees. Number 8, 690, again, is bigger than 360, so we're going to still start in standard position. It's just going to rotate, have a full rotation larger than our starting position. So let's take 690 and let's subtract 360. What happens when I do a full rotation up and over? That still leaves me with 330 degrees. So we can still go another 180, or we can even go 270. Keep going to 270. Subtract that. What do we have left? I still need to go 60 more degrees. So here's a third. There's 30. Here's another third. That would be 60. Go almost all the way. So we start in our standard position. We did a full circle 360 plus 270 plus another 60 takes us to this position for a full 690 degrees. I'm going to write it one more time. We did 360 plus 270 plus 60 more degrees took us to the full 690. Number 9, sketch negative 810. So we are going to go down and around, starting position, going down. Now this is obviously bigger than 360, so let's take negative 810. And since it's negative, let's add 360. That is going to help us get a smaller angle. So negative 810 plus 360 gives me negative 450. So I know I'm going to have to make one full rotation. Let's add another 360. Takes us to negative 90. So let me add that full rotation. We had to do 2 full circles, and then I still need to go negative 90 degrees, so straight down. So from starting position, we did 1 full rotation, 2 full rotations, and then added another 90 degrees to take us straight down to this position to give us negative 810 degrees. I'm going to write that one more time. We did negative 360, we did negative 360, and then a negative 90, added all up to negative 810. Number 10, sketch negative 1,110. Very large number, lots of rotations. We're going to start in that standard position. I'll do the same strategy. I'm going to take negative 1,110 and add 360 and see how many rotations we need. It is negative, so we're going to go down and around. So I know it's already 1. That leaves me with negative 750. Let's add another 360. Gives me negative 390. So we've done 1 rotation, 2 rotations. Let me add to our sketch here. 2 full rotations, and we still have negative 390. Let me do 1 more full rotation, and that's going to leave me with negative 30. So I need a third full rotation and then a negative 30, a third of the way through my quadrant. Okay, so here we went 1 loop, 2 loops, 3 full rotations, and then 30 degrees more takes us to this position for negative 1,110 degrees. Let's review. We did negative 360 for one rotation, a second rotation, a third rotation, and then an additional negative 30 gave us a negative 1,110 degrees. On the next page, we're going to talk about coterminal angles. They are different angles that share the same terminal side or ending position. So meaning they just land in the same place. We were doing something very similar previously. So they can go in the same direction or opposite direction. So they can both be positive or they can both be negative, or they can be opposites, positive and negative here. To find coterminal angles, so we just mean angles that have the same ending position, they have the same final landing place. We're just going to add or subtract 360. We're just going to add or subtract a full rotation. So let's look at number 11. Find a coterminal angle for 90 degrees. Let's first sketch 90 degrees. There it is, nice and beautiful, 90 degrees. Now, who else would have that same position from our starting position to straight up? Well, let's look at positive, another positive angle. So we could take 90 degrees and add 360 to it to give us 450 degrees. So still starting in that standard position, we would just rotate a full 360 and add another 90 degrees. Do you see how that lands in the same position there? So 450 degrees is coterminal, has the same ending position as 90 degrees. We could also make a negative value. If I take 90 degrees and subtract 360, gives me negative 270. So we could start at our standard position and rotate negative 270, and that is also going to take us to that straight up positive 90 degree ending place. I did that one in light blue, and they're all landing in that same place. They're all coterminal, have the same ending position. Let's look at number 12. The value is negative 315. Let's sketch it first. Now it's negative, so if I go down, that's negative 90. All the way over is negative 180, straight up negative 270. And then if I add 45 degrees more, would take us to 315. So from standard position going down and around, here's where negative 315 is. So let's come up with a coterminal angle and let's make it positive. Negative 315 plus 360 gives me 45. Let's check that. If I start at the standard position and I graph a positive 45 degrees, is that not in the same position? Absolutely. 45 degrees is coterminal with negative 315. If I do a negative value, if I was to subtract 365, if I was to subtract 360 from negative 315, we would get negative 675. So if I start at the standard position and I did a full rotation 360 plus 315, so 270 plus the extra 45, that will take me to the same place, coterminal. Negative 675 is coterminal with negative 315. Number 13, we're doing the same thing. It's just in word form. Find an angle theta. So when we don't know what our angle measurement is, we use the Greek symbol theta to just symbolize our angle. So find an angle theta coterminal to 960, where 0 is less than or equal to theta less than or equal to 60. This is saying we're looking for an angle between 0 and 360. Okay, very important. So we're trying to have a positive angle between 0 and 360. So take 996 to find coterminals, just add or subtract 360. Since I'm trying to make it between 0 and 360, let's subtract 360. That gives us 636. Are we done? Are we between 0 and 360? Not yet. So subtract 360 again, gives us 276 degrees. 276 is coterminal with 996, and it also falls between 0 and 360. Number 14, find an angle theta coterminal to 1,227, where 0 is less than or equal to theta, less than or equal to 360. So take that number and let's subtract 360. Gives us 867, not small enough yet. Subtract another 360. Gives us 507, still not small enough. Subtract another 360. Gives us 147 degrees. Is coterminal with 1,227 and is between 0 and 360. Number 15, find an angle coterminal with negative 169 between 0 and 360. Now we got to make it positive. So add 360 to this and we get 191 degrees and done. 16, negative 531 between 0 and 360. So add 360, gives us negative 171. Still doesn't quite cut it. So add another 360. 189 degrees is coterminal, and it fell between 0 and 360. The last section of our notes, we are going to convert between degrees and radians. Radians should sound familiar from last year in geometry. Radians is another way that we can measure angles. So I know we get very used to hearing about degrees, but there is also radians that you can use to measure the size of your angles. Just like if I wanted to measure length, I can choose to measure length in inches, feet, meters, yards. There's lots of different ways to measure length. We can also measure our angles with degrees or radians. Now, important information here, 180 degrees is equal to pi radians, a pi-like number of radians. 180 degrees is equal to pi radians, which also means 360 degrees would be equivalent to 2 pi radians. Now we are going to convert between the two, and you can convert to radians by multiplying by pi over 180. So we just said that those are equivalent. 180 is equal to pi is equal to 180. And then if we want to change something into degrees, we are going to multiply our value by 180 over pi. So I'll give you some tips here in a minute. Now, radians will always have pi in the answer. You are not allowed to have decimal answers. You better have a pi in your answer if you're talking about radians. So let's start by converting to radians. We're going to change 20 degrees to radians. Now to change something to radians, you are going to multiply by pi over 180. So it's always a pi and it's always a 180. So how do you remember which goes on top and which one goes on the bottom? If I'm changing it to radians, I just said your answer has to have pi. So I want to make sure that I have pi, leave pi in the numerator. Okay, multiplying fractions across the top and across the bottom, you got 20 pi over 180, and then simplify from there, we get pi over 9 radians. 20 degrees is equal to pi over 9. Number 2, negative 315 degrees, we're going to change to radians, pi over 180. I'm changing it to radians. My answer has to have pi in it. So leave the pi on the top. You'll get negative 15 pi over 180. So I brought up your Inspire calculator. Guys, our Inspire's default to fractions. So if you just put in negative 315 over 180, that's the pieces that we're trying to simplify and reduce here. It's going to simplify to negative 7 pi over 4. So I was just reducing our numerical pieces there. So negative 7 pi over 4 radians is equal to negative 315 degrees. Number 3, 90 degrees. Changing it to radians, multiply by pi over 180 gives us 90 pi over 180. You need to reduce the 90 and the 180. So on the calculator, if you just type in 90 divided by 180, it will reduce that for us to 1/2, or you have pi over 2. Number 4, we're now going to change it to degrees. So if I have 3 pi over 4 and I'm changing it to degrees, I'm going to multiply by 180 over pi. We're just flipping that conversion factor over. Now this one's easy for me to remember because I'm changing it to degrees. I do not need the pi symbol anymore. I need it to cancel out. So the pi in my radians was in the numerator. I need a pi in the denominator so they will go away. So let's look at, what are we going to have? -3 times 180 on the top over 4. Let me grab the calculator and we'll simplify this down. I'm going to do control divide so I make sure everything stays in the numerator. -3 times 180 over 4. -135 degrees. Number 5, we have pi over 8. We are going to change it to degrees, multiply by 180 over pi. I need pi in the denominator, so my pi's will cancel out. This gives me 180 over 8. Let me grab the calculator and we will simplify. 180 divided by 8 is 45 over 2. You can do menu 2, 1 to get you to simplify to 22.5 degrees. Number 6, 2 pi over 5. We're going to multiply that by 180 over pi. I need pi in the denominator, so my pi's will cancel out so I can have a degree. 2 times 180 over 5, that's going to be 360 over 5. Let me grab the calculator. We'll simplify that. 360 divided by 5, 72 degrees. So we did quite a lot today looking at degrees and radians. We sketched some angles. We sketched positive angles, negative angles, and angles that were bigger than 360 or bigger than -360. We talked about coterminal angles end in the same position. You can find those by adding or subtracting 360. And then we also converted between degrees and radians using those conversion factors of pi over 180 or 180 over pi. Practice those, guys, and let me know if you have any questions. I'll see you in class.